Yay. Okay. Welcome. Welcome. I want to take this opportunity to thank you for this. I'm switching back and forth between okay, perfect. Anyway, it's 1:31 Eastern time. And this is actually the second time I'm doing this. I've done this webinar a couple of hours ago, actually an hour and a half ago, when the last one that I did ended. Yeah, thanks for taking your time off of your busy day. And I appreciate that. While you guys are, well, we are waiting for this, let me just do a quick poll. All right, feel free to answer the questions in the poll. Not yet. Huh. You are one lucky guy. Anyway, okay, we're just actually waiting for a few more to join us before we get things started. And I've already opened up the poll just to ask, have you experienced a database corruption issue before? That's actually a pretty cool question to ask, not because I haven't. In fact, I think the first time I've experienced corruption was, I think, back in 2003, 2004. Database corruption, until it became a regular thing, not every month happening, but different customers in different environments. Okay. And I'm just waiting for more folks to come in. And while we're waiting, I'd appreciate if you could type in the chat window where you're from, what time zone you're in, and are you a full-time SQL Server DBA, or are you an IT pro that is responsible for dealing with databases? I'd appreciate if you could post those information. David, thanks for joining us. Again, as I was mentioning earlier, feel free to answer the question in the poll. Have you experienced a database corruption issue before? I'm just taking a pulse on people attending, where they're at, and how they're dealing with database corruption, or if they've even experienced database corruption before. And like I said, while you're at it, I'd appreciate if you could type in the chat window where you're from, what time zone you're in, or in rather, and are you a full-time SQL Server DBA, a dedicated SQL Server DBA, or are you accidental? I don't want to call it accidental because it's still a choice, right? Baltimore, IT pro. Thanks, Visual. Baltimore, so we're on the same time zone, Eastern time zone. Yay. Who else? It's got, all right. It's 1:34 Eastern time, and I'm just gonna wait till like 1:35 before I kick off this presentation. Yay. Again, for those of you coming in, feel free to answer the question or answer that poll. It's a simple yes or no question. Have you experienced a database corruption issue before? It's an interesting question that I want to be interested in, just so I have an idea of where you are at the moment. I mean, in terms of corruption experiences. Perfect. All right. I think I think we can start. We can get started. Okay, so 100%. No, you have not experienced a database corruption issue before. Okay. Anybody else who might want to say, yes, I have? Perfect. Tatiana, DBA database. Oh, Tatiana, how are you? Reginald from Antigua in the Caribbean. A lot of people are on the Eastern time zone, so we're right on the spot here. All right, perfect. So 100% said they have not experienced. Lucky you. Anyway. All right, so I just want to quickly give you an overview of what we're going to cover today. And while we're at it, I'll just share my screen. And hopefully you can see my screen now. There we go. So this session came out of some of my discussions with friends, colleagues, customers who've experienced corruption recently. And I felt like I needed to talk about this in one way or another in one of my presentations. So I mentioned this is the second webinar that I'm doing today. So again, if you have any questions during or even after the presentation, feel free to send me an email or even type your questions in the chat window. I'll be, because I'm sharing my screen at the moment and I'm sharing my slide deck, I will be jumping back into the webinar control panel later on to take a look at the questions. Again, feel free to send those questions in. First of all, really appreciate you taking your time off of your busy day to take a look at or join me in this webinar. Earlier today, there were people asking questions about, can you do a replay? This is recorded. So if you say, for example, if you need to go back and review some of the topics that we're going to cover, the replay is there for you. And because you've seen my my online course on Udemy, if I'm not mistaken, there is a demo, I forgot the lesson number or the lecture number, where I talk about database recovery techniques, and this is just one of them. Database recovery techniques and dealing with database corruption issues. But anyway, let's get started. So I wanted to dive into the idea that your databases is much like a warehouse. In North America, you've probably seen a lot of those storage facilities, whether it's the enterprise storage facilities for bigger customer base, or even the consumer storage facilities. But I wanted to look at databases similar to those warehouses, where if I don't have enough room in my basement, for example. I actually do, but let's say, let's assume that I don't have enough room in my basement or in my garage and got a lot of stuff. What I do is I will look for a storage facility that I would rent out. And what I'll do is I will rent the space and I'll take my stuff with me. Of course, being somebody who's responsible for my stuff, what I'll do is I'll make a checklist of all the things I'm going to be bringing there. And as the storage facility will then take my stuff, put them in certain sections in that storage facility, maybe room number 5, aisle number 6, stack number 5, and so on, and then put my name on. And then within that, he's going to give me a list of the things that I've stored in the storage facility, and I'll use that as a reference. I mean, no different from you going to the supermarket and going to aisle number 6 where all the ketchup and condiments are similar in nature, right? Whenever you're dealing with warehouses or any storage facility, it goes through the normal wear and tear. And I say normal wear and tear because, well, if I will be storing more stuff in the storage facility, taking it out, putting it back in, that's your normal wear and tear. I like to call that physical corruption. Of course, as it ages, storage facility, as it ages, weather conditions or activities within the storage facility, that would eventually wear the entire facility. Of course, it's not just me that's going to be storing stuff in the facility, but there's more people. I want to call that physical corruption because I wanted to focus on physical corruption, not logical corruption. In terms of databases, you got physical and logical corruption. Logical corruption is when your business logic does not match what's stored in the database. For example, logical corruption may mean that if I'm storing integer, I accidentally stored some value, but it's in text, something like that. But I want to focus more on physical corruption as far as databases are concerned. What is database corruption? And I've taken a very simple definition of what database corruption is. It's a problem associated with inconsistent storage of ones and zeros that represent your database data in the I/O subsystem. I mean, think of it this way. If you're inserting, updating, deleting records inside your database, we might think, oh, I'm just inserting records. But at the end of the day, the records get translated in nothing more than ones and zeros, because that's how computers understand your data, the bits of ones and zeros. The idea being is I want to make sure that whatever I stored in my database is exactly what I read from my database. I want it to be exactly the same thing. Now, let me go back to that storage warehouse analogy that I was mentioning. Let's say I've got my piece of paper that the storage facility gave me, and they said, I'm storing your stuff in, again, storage A, aisle 6, stack 9. I want to make sure that I can go to storage 6, aisle 5, stack 9, and find my stuff in there. Because that's exactly how I stored my stuff. I want to make sure that the way I stored my stuff is exactly the same way I will retrieve my stuff. Now, what if I can't find what I'm looking for? Why would that be? Well, for example, if they're referencing barcodes with my stuff, and then the barcode is no longer readable, how can I find what I'm looking for? And so what I stored is no longer the same as what I'm reading, or in this case, what I'm retrieving from the storage facility. And I call that, again, as I mentioned, physical corruption. And I want to focus on, again, physical corruption in terms of how your databases work. I'm pretty sure you probably experienced that at some point. You go to the grocery store, somebody tells you, oh, the condiments are on aisle 6, row 5, and you go there and it's not there because the grocery clerk or the grocery staff, based on what they know, this is where the condiments are, but then you can't find it there. So there's inconsistency between what they thought they wrote versus how they're retrieving information from what is written. And so let me start off with the premise that almost all database corruption problems are caused by the I/O subsystem. And I said almost all. And I also highlighted I/O subsystem. Why I/O subsystem and not this? You might be thinking, well, I'm actually storing my data in a database file, and the database file is inside a hard drive. Well, think of it this way. The I/O subsystem is not just your disk drives. The I/O subsystem is anything that SQL Server uses to store data. And what do I mean by anything? It's anything that sits between SQL Server and the disk. What are those? Number one, well, SQL Server still runs on top of the Windows operating system. And in order for SQL Server to be able to write data into those disks, it has to talk to Windows, and it has to tell Windows, look, I need to write this to disk. On top of that, Windows uses file system filter drivers. NTFS, the requirement for installing SQL Server on Windows. Back then, you can install SQL Server on FAT, File Allocation Table System. These are file system drivers. And SQL Server will tell Windows, and then Windows will then use the file system drivers to write data on disk. But it doesn't stop there, because if you're dealing with storage that's on the network, like iSCSI, for example, or NAS, or anything that's remotely connected, or connected remotely to your underlying SQL Server instance, like SQL Server 2012 introduced SMB file shares. And because SQL Server has to go through the network layer, has to connect to the network adapters on the remote storage, has to connect to the network adapters on the local server, has to go through the switches, the routers, and the cables. All of that form part of the network layer. And then you got controllers, whether it's on storage area network, whether it's a RAID controller or local attached storage. A controller will be responsible for sending that data into disk drive. And again, the underlying storage is your disk drive. This is where your database files will be stored. Now, come to think of it, I mentioned IO subsystem, which is anything that SQL Server uses to store data, which means when you run an insert, update, or delete statement, has to go through the Windows operating system, the file system filter driver, the network layer, if it goes through the network, because they're using network attached storage like iSCSI, and controllers before it even reaches the disk subsystem or storage. Now, here's the thing. The more components you introduce in your underlying IO subsystem, the higher the possibility of you encountering corruption. And the reason for that is, of course, a lot of moving parts, a lot of different components that were made by humans. And humans, of course, make mistakes. It's one of the reasons why your storage vendor or your network vendor or even Microsoft will release regular bug fixes or cumulative updates to fix those issues. Again, anything that SQL Server uses between itself and the underlying disk drive is included in the IO subsystem. Now, we know for a fact that the disk drive is the final destination of your data. Question is, what are we trying to do? What are we doing to protect it? Now, I know a couple of you are probably developers that do not know how your disk subsystem is designed. You're not even aware because it's virtualized how the underlying storage was configured. But gotta ask whoever's responsible for the IO subsystem, what are you trying to do to protect it? And that's where the redundant array of independent or inexpensive disks come in, because whether it's RAID 5, RAID 10, or whatever type of RAID that you're implementing, your goal is to make sure that the disk is protected and redundant. And I say or and redundant. Now, the goal for this session, the goal for the entire presentation, is not to prevent corruption. As I mentioned, corruption is simply caused by the fact that everything that SQL Server uses is made by humans. Even if it was made by robots or anything automated, they're still made by humans and they're prone to make mistakes. The goal is to detect corruption when it happens. It's not really an issue of whether or not you get corruption. It's an issue of when you're going to get corruption. And I asked the poll earlier if you have or have not experienced corruption. Majority of you have mentioned you have not. And so it's really a matter of when it's going to happen. But let's get back to the database. I just threw out that idea about how your underlying disk subsystem works, so that we can start dealing with corruption when it happens. First thing, of course, identifying it. Let's start with the concept of page protection. And page protection is simply ensuring the integrity of the page or data page from the time it is written to disk to the time it is read again. Again, going back to my analogy of me taking my stuff to a storage facility and then making sure that whatever I put in there is exactly what I'm going to take back. It's mine, right? There's a TechNet article that I would strongly recommend that you read on SQL Server buffer management. And while this article was written for SQL Server 2008, it still applies to SQL Server 2014, 12, or even 2016. The idea being, and this is the name page protection is a bit of a misnomer, because at the end of the day, SQL Server is not going to tell you that the page is protected and therefore no corruption would ever happen to it. Not at all. That is not the case. Page protection is simply a means of telling us or SQL Server when it reads the data that something went wrong. Okay, now there's two types. I did say two, not three, because I don't even want to talk about the third one. There are two types of page protection that we should be concerned about. Number one is torn page detection, which was introduced in SQL Server 2000. Imagine a data page, 8K data page, being written to disk. Now imagine, instead of just looking at an 8K page, but thinking of it as a page that consists of 16 512 bytes disk sectors. The goal is to write all of those 16 512 bytes disk sectors in a contiguous fashion. Okay, torn page detection simply does this. If SQL Server has to write 16 contiguous disk sectors of 512 bytes each, SQL Server will make sure that they all get written properly. If not, SQL Server will return a corruption error or will detect corruption. So imagine 16, 1, 2, 3, 4, 5, 6, 7, 8, 9. The 10th disk sector was not written properly, and therefore SQL Server will report that as torn page detection. SQL Server 2005 introduced the concept of a checksum page protection. And what this simply does is when SQL Server writes data in a page, in an 8K data page, the last thing that SQL Server does when the page is written is to calculate a checksum based on the data that was written. When the checksum is calculated, it gets stored in the page header. So that's the last thing that SQL Server does when you're writing. So when you're inserting records, insert into table, and it has to write on the data page. That's the last thing it'll do. And when you do a select star from table, and SQL Server needs to read the data off of the page, what SQL Server does is it will read, the first thing is it will read the page checksum on the page header. And then it will calculate the checksum based on the contents of the data page, and then makes a quick comparison. If those two don't match, SQL Server will report corruption. And again, all this is simply doing is making sure that what you've written is exactly the same as what you will read. Now, this is recommended for SQL Server 2005 and higher databases. And I mentioned and higher. And the reason I'm saying this is you may have databases that came from SQL 2000, took a backup, restored in 2005, 2008, 2012, upgraded, but page protection was not changed from what it was to checksum. And so the recommendation is to make sure that checksum page protection is configured for all of your databases. So let's take a look at a very simple demo. I'm going to switch to my demo environment and show you how we can verify. So it's as simple as querying your sys.databases DMD in the master database. I'm just going to run a select query, and just to show you, might be seeing Northwind and Pubs, the all too familiar Northwind and Pubs database. I've got torn page detection. There's a reason I've included those. Again, a use case or a situation where you've taken a backup from an old database, or maybe you've upgraded a database running in SQL 2000, and then moved that to a new version, but then you did not change page verify option or the page protection option from the old one, in this case, torn page detection, to checksum. So how do we change that? Well, it's as easy as doing an alt to database. Alt to database, the name of the database, say set page verify checksum, and I'm going to do that. And check. Now, Northwind and Pubs have page protection option page protection option set to checksum. Now, word of caution, just because you turn on the switch doesn't mean it did anything. Not at all. What this simply does is the next time you start writing pages to disk on your SQL Server database, SQL Server will perform checksum on those pages. What does that mean? Well, that actually means whatever data you already have on your databases are there and have not been modified. What that also means is you may have corruption on those existing pages without you even knowing. So the next thing you need to do after changing your databases to checksum is, number one, run DBCC Check DB. And number two, make sure that the pages get rewritten back. Well, you might be thinking, how do I even do that? Well, you can run your index rebuilds. And when you're running your index rebuilds, you're rebuilding your clustered and your non-clustered indexes. It's rewriting those pages to disk. And because it's rewriting those pages to disk as part of the re-index maintenance process, it's performing the checksum as it's writing those pages to disk. And so that's the way to make sure that after you flip on the switch and change your databases to checksum, to make sure that everything that's already in there has the checksum page protection turned on. One thing to keep in mind, make sure that your databases are being monitored, and make sure that you know if there is a database out in your environment that still has anything other than checksum configured. So it's just, and you've seen it, it's as easy as running a select statement on the sys.databases database, master database rather, running a query on the sys.databases. So that's just verifying and modifying, and it all starts from there. It all starts from there. If you could identify which one does not have the page protection option, it starts from turning that on. Now, what about identifying IO errors? I mentioned earlier that almost all of the corruption is caused by the underlying disk subsystem. And the sooner we know that there are issues with the underlying disk subsystem, the better we can deal with it. And the one way of dealing with it and getting informed is by identifying IO errors. We start off with error 823. This is commonly known as the hard error. Why hard error? Well, because when SQL Server has this, it doesn't even perform anything, it just stops. And it may indicate hardware problems or system problems in SQL Server. KB article 828339 is a reference point for dealing with 823 errors or 823 errors. 824 errors is commonly known as the soft error. You got hard and you got soft errors. So 824 errors, basically you can still run your queries, you can still run your checks, but then SQL Server will tell you there is something wrong with the underlying disk subsystem. And 2015756 KB article will walk you through how to troubleshoot message 824 in SQL Server. Finally, it's 825, or the read retry error message. Now, I might be specifying, or I might be mentioning 823, 824, and 825. The goal is to be alerted when it happens, not when it's about 5 months down the road and you don't even know when it started. The goal, again, is to make sure that you get alerted, informed when it happens so that you can deal with it immediately. And again, this is more of a proactive approach of dealing with these errors. So let me walk you through how you can detect IO errors. And Tim Redding, SQL Server MVP, wrote a blog post on how to use SQL Server agent alerts for getting notified when these errors happen. So let me switch back to my demo environment. And let me just quickly show you. Let me just do that. Let me just quickly show you what I mean. Now, here's a very simple database, very simple query. And this is more of a contrived example because I caused corruption on this particular database. Let me run a query, and you noticed nothing seems to be wrong with this database. But just because there is corruption in the database doesn't mean it will get detected. You have to explicitly read the corrupted page in order for you to find out that there is indeed corruption, as in this particular case. Well, I intentionally corrupted the last page in this particular table so that querying the first 10 will not even hit the corrupted page. Now let's try that again. Instead of just querying the top 10, let's query all of the records in this particular table. I see it's taking time, boom, there you go. It tells me that there is, as I mentioned earlier, the checksum option. This is what was expected because this was what was in the page header. And this was the actual, which means this was the one that was a result of the calculation when the page was read. And it tells me that there is indeed a checksum error. And then it tells me the file in C program files, demo sample db.mdf, and more information. It's really interesting because starting with SQL Server 2005, error messages have become more intuitive. Back in the days, it just tells you contact your system administrator, which in that case is us. How do I contact my system administrator if I don't even know what is wrong with it? But SQL Server 2005 and higher came up with very useful error message. This is an example of an 824 error message. Now, let's look at the suspect pages table in MSDB. And this is one thing that I would so recommend that you include in your monitoring systems or your monitoring tools. You read the suspect table in MSDB. Okay, could be as simple as select star. In this case, I've simply created a case statement to translate the error codes in the event type column in suspect pages table. And notice that because I've encountered corruption, my client connection got disconnected. Okay, so if this is a web application querying the database and there is a corruption, your application will automatically get disconnected. Let's run this. So this is the suspect pages table in MSDB. Page 278 was the page that was corrupted. Event type 2, which means bad checksum. And you've seen how the calculated and the actual, or rather the stored versus the calculated values were not the same. And therefore, it is telling me that it has encountered a bad checksum. Okay. So how do we get informed, or how do we get alerted with this? Well, we can start by creating a SQL Server agent alert and tell this they're 824, for example. I'll use error number 824 and then click OK. Okay, that's one. You can create one for 823, 824, and 825. Now I've created 824, and if you want, you can get one of your DBAs, or I mentioned one of your DBAs because I don't expect you to be the only DBA to have to deal with this. So send that email notification to your mailing list or your DBA group instead of just you, and you can notify your operators with it. Another way of dealing with that is, of course, using the SP add alert system stored procedure in MSDB. So you could create those and create one for 823, one for 824, and one for 825. And again, just a way to make sure that you do get alerted when SQL Server encounters those IO errors as it's performing some of this maintenance in your some of your queries. As I mentioned, the goal for this presentation is to make sure that you are proactively identifying, detecting, and dealing with database corruption. So we've talked about how to identify them, making sure that you get alerted when corruption happens or when IO error happens, because of the fact that majority of the corruption that's happening on your database is caused by the underlying IO subsystem. If you get an error message that pertains to IO subsystem, there might be a potential corruption issue. And that's why we need to go beyond being informed of the IO errors. And that's where the DBCC Check DB command comes in. There's a full MSDN article or Books Online article on how that works and the different parameters that you pass into it. The goal is to run it regularly. Now, of course, regularly might be relative depending on how large your databases are. My kind of rule of thumb is if it's less than 500 gigabyte, just run it every week. But that also depends on what your maintenance windows are and what your availability goals are. Because keep in mind that running CheckDB is definitely going to use up resources in your system. And that's why you have like weekend maintenance windows to perform this. Run it regularly. If you're dealing with large databases, you might break down your consistency checks and not run CheckDB, but rather run CheckTable or the other things that the CheckDB runs. That way you can break it down to your critical versus non-critical tables, and then you run the critical tables maybe once a week and non-critical ones maybe every 2 weeks. Again, the goal being is to make sure that you run it regularly. You also need to run it on all databases, and I mean all databases. The one thing that a lot of people are not aware of is when they create a database maintenance plan and they select all databases, and I'm going to show you that in the demo, all databases does not include TempDB. Now you might be thinking, well, why do I need TempDB? Or why do I need the master database? Most people would say, well, I got a maintenance plan that runs CheckDB on all my user databases, fine. But keep in mind, if the master database is not online, if it was corrupted, your SQL Server instance will not start. And so it really doesn't matter if your databases are fine. If the SQL Server instance is down, your database is inaccessible. Same thing with TempDB. You might be thinking, well, TempDB gets recreated every time SQL Server restarts. Why do I need to deal with TempDB? Well, same thing. If your TempDB is corrupted, your SQL Server instance will not be able to start, and therefore your databases will not be accessible. So make sure that you run it on all databases, not just on user databases. So let me just show you how you can quickly or manually run DBCC Check DB and how we could use SQL Server Agent to run DBCC Check DB. Again, let me go back to my demo environment. This is a very simple command, DBCC Check DB, and then you pass the name of the database. If you've got a database with spaces or dashes in the name, you might want to use the square brackets as a part of DBCC Check DB. Let me just run this. Now, by running DBCC Check DB, it actually tells you exactly what DBCC Check DB does. First off, it starts by checking all of the service broker related objects. In my case, I don't use service broker. There's only a handful of customers that I've dealt with in the past actively use service broker. But in this case, I can simply ignore this. And the reason I'm saying this is, and the reason I'm showing you this is if you decide to break down DBCC Check DB and run CheckTable, CheckAlloc instead of whole CheckDB because it's going beyond your regular maintenance window, this is how it's done. And then it first starts off by checking the consistency on the metadata tables inside your database. So sys.sys rscalls, sys.sys row sets, sys.sys clones. It goes through all of the tables on your underlying data, or metadata tables on your underlying database before it even starts going through your user objects. So after sys.sys soft obj refs, I don't know what name that is, that's the only time that it starts looking at the orders table, the products table, the order details table, and so on and so on. Now, this is how easy it is to run DBCC Check DB. The goal is not to read the results of CheckDB when everything's fine and everything is going well. The goal is to make sure that we're not bombarded with successful messages. We're only concerned with dealing with corruption if indeed corruption happens. That's why you use the with no info messages parameter when you're running DBCC Check DB. Okay, this is a manual way of running Check DB. And of course, I don't want to be going to my databases every week, especially on weekends when I have to enjoy my cup of coffee and go out in the lawn and play. I don't want to be able to do that. I just want to make sure that it gets run. So what I'll do is I can create maintenance plans. And this is the part where I tell you, well, your maintenance plan actually does not include TempDB when checking database integrity. So let me say drag check database integrity task, and let me select, keep in mind, all databases. I don't want to be running Check DB on databases that are offline, but I want to use all databases and ignore databases where the state is not online. And here's what I want to show you. When you look at the task or the SQL transact SQL statement generated, you see master, you see model, you see MSDB, Northwind, but there's no TempDB. No TempDB at all. Which proves the point that if you're using the database maintenance plan and you're running the check database integrity task, even if you say do this on all databases, it's not going to run it on the TempDB database. So you have to explicitly tell it and create a SQL Server agent job on the top of your database maintenance plan to deal with running DBCC Check DB on the TempDB database. Of course, when you save this, it actually creates a SQL Server agent job. We could schedule that, say, weekly on a Saturday at, say, 9 p.m., maybe 9:12. The reason I'm not using the exact 9 o'clock, 10 o'clock on the dot is because you may have other jobs running, and I want to make sure that this does not interfere with the schedule that you currently are running. Click OK, and as I mentioned, this will create a SQL Server agent job that corresponds to running that. So when you do a quick refresh, and that's where your job gets created, DBCC Check DB. Okay. So that's how you manually run, and that's how you use SQL Server agent to run DBCC Check DB. As I mentioned, maintenance plans will not run Check DB against a TempDB database. So you have to do that manually. Now, what if we've talked about how to identify, how to detect, how to get informed, how to run Check DB. What if there is database corruption? And again, the overall goal is not to prevent corruption, because it's inevitable. You're always going to have database corruption. It's just a matter of when. How do we deal with database corruption? The goal is to learn. What I'm giving you is information for you to learn, but then learning is one aspect of it. The next aspect, or the other aspect of it, is practicing. Dealing with database corruption does not require or does not work well if you panic. That's the reason why I'm showing you all of this, so that you can practice on your own, so that you know exactly how to deal with it when it happens. Kind of like talking about disaster recovery or high availability, like firefighters. You know, they practice, they do all their drills, hoping and praying that they don't have to ever use it. But when it does come to a point when they have to, they're ready for it. So that is the overall goal, why we're learning this, so that we can practice. Now, let's deal with database corruption. What I've shown you so far is how to identify, how to get notified, how to run it on a regular basis. That's proactively identifying. How do we deal with it? Say, I've gotten a call, or maybe I've gotten an email alert from our monitoring system telling me that there is corruption, and I've verified that there is indeed corruption. How do we deal with it? I'm going to show you two things here. One is dealing with corrupted non-clustered index, and the other one is performing page level restores. So let me switch to my demo environment, and show you one example of what I mean. Now, just because you're seeing corruption doesn't mean that you have to restore from backup. I'll just quickly show you what the error message is. I'll look unit ID. Okay, I'm just formatting the error message so we can see what DBCC Check DB is actually telling us. Test DB, found my Check DB, and so on and so on. Okay. The nice thing, as I mentioned, the nice thing about the Check DB message is it tells me a lot about what I need to deal with. And so let me start by, let me open Notepad real quick and just copy a lot of this information. Right, table error. Object ID. Back in the days, you have to guess by just looking at the page ID. Now I got object ID 309576141. Index ID 2. Well, index ID 2 is a non-clustered index, because index ID 1 is a clustered index, because you can only have one clustered index per table. Now, if you see something like this, my initial reaction back in the years was, what am I going to do? Do I restore from backup? I mean, take a step back and relax. Know what SQL Server is telling you about the corruption. In this case, SQL Server is telling me that there is a corruption on a non-clustered index page. Is it worth restoring a 400 or 600 gigabyte backup just to restore a non-clustered index page that is corrupted? Probably not, because it's going to take some time for you to restore that backup, and that will factor into your high availability. So because SQL Server is reporting that there is a corruption on my non-clustered index, I can simply use the no index option when running DBCC Check DB. And the only reason I'm running this is to verify if indeed only the indexes got corrupted. In this case, no, Check DB with no index told me, look, everything's fine. The only thing that got corrupted is your non-clustered index. So let's try and identify the non-clustered index. First off, let's run this query. Test DB, running, and then it hits that message or that error and tells me that there is, similar to what we had earlier, an incorrect checksum. Okay. It tells me the page 3060. Now, the reason why it's hitting that corruption is because by default, SQL Server will use available indexes as long as it thinks that it's worth using. In this case, the non-clustered index actually has the last name and the first name in the definition. Now, what if? Let's turn on execution plan. What if we bypass the index and read the first name and the last name from the underlying table? Notice how my application got disconnected. Now let's rerun this, and of course the 824 error message. So let's rerun the same query, but this time bypassing the corrupted index and using the clustered index. So this is using a clustered index scan. So we know that the corrupted page is indeed coming from a non-clustered index. So let's use some of the information that we got from DBCC Check DB. 809-57641. 809-57641 is the object ID reported by DBCC Check DB. Let's run that. Contact. So that object happens to be the contact table. And let's take a look at the index name. 309-576-141, which is the object ID, and index ID 2. Let's run that. The name of my non-clustered index is NCIX_name. So instead of me panicking, trying to look for the latest full database backup, restoring from backup, fixing all that, because now I've known that it's just a simple non-clustered index, all I could do is instead of taking the database offline and restoring from backup, is just rebuild the non-clustered index. In this case, I am disabling, and you might be thinking, so why are you disabling? Well, for one, if that non-clustered index is on a foreign key constraint that's enforcing data integrity, you don't want to be dropping and recreating it, because when you're doing so, what if somebody comes in with a transaction and inserts a record that violates your data integrity through the foreign key constraint? Then that's more of a logical inconsistency. You might not have a physical corruption, but you now have a logical corruption. So, and we're rebuilding it. Okay, run that, and run same query. Well, for one, let's take a look at Check DB. I don't have any corruptions at all after fixing that corrupted non-clustered index, and I could now validate that the query is indeed using the non-clustered index that I just rebuilt. Again, key thing to keep in mind is don't panic. Identify what DBCC Check DB is telling you, and then respond based on that information. Okay, it's not worth restoring a 400 or 600 gigabyte size backup when all that's corrupted are non-clustered indexes. So let's take that a notch higher. What if, instead of a non-clustered index that's corrupted, the corrupted page happens to be a clustered index? Well, I can't just drop and rebuild that because it's my base table. Okay, so let's see how that thing works. Let's look at a sample database. And again, these are all contrived examples because I've intentionally corrupted these databases. Let's use this database. Run, and boop, there you go. We get another inconsistency or logical consistency IO error. Again, your error 824, severity 24, checksum is invalid. It tells me it's in page 297, file 1 of database ID 9. Like I said, a lot of information is available when dealing with corruption like this and running DBCC Check DB. As I did earlier, I made sure that the corruption happened on the last part of the table, or the earlier part of the table, and that's why I'm getting the corruption. But, okay, in this case, I'm not just dealing with a non-clustered index. Let's validate that. DBCC Check DB would tell me that there is a problem with index ID 1. Big difference, right? Index ID 1 is a clustered index, and my clustered index is my underlying data in my table. Tells me object ID 405, 5766483. Now, I won't even bother at this point because I know it's a clustered index, and therefore my underlying table is corrupted. I don't even want to know. Okay? Of course, at some point I may want to know, because what if it is a non-critical table? I could probably just drop that table and recreate it based on information from other sources. But in this case, let's take a look at some of the error messages or the messages information that we could find from this. Page 297 got corrupted. And what else do we see here? Page 297 got corrupted. And like I said, I'm just reformatting this. 297 got corrupted. 298 is also being referred to in the error message, but you got to think of it in this way. 298 is actually pointing to 297. So it's the previous page, which means the pointer to 297 isn't working. And 288 is the parent. It points to 297. And so imagine your B tree with all the linkages, and the linkages are broken. So in this case, because it's a clustered index, we can't just drop and recreate it because it's a clustered index. And again, as I mentioned, if this is a non-critical table, well, you could probably drop and recreate the table and then reload it from data from different sources. But let's say this is a mission critical table. First thing that we need to do is, what is actually in that page? So let's use the undocumented DBCC page to see what's inside the page. Now, they're undocumented, which means there are no documentation available from MSDN, TechNet, or Books Online, but there are a lot of SQL Server MVPs and Microsoft Certified Masters who have written blog posts about DBCC page. So let's take a look at that. So DBCC page is simply reading page 297 from file 1 on this database with a complete information. In this case, the query completed with errors, which means I cannot even read some of the data in there. So this is what I was mentioning earlier about the page header, but it stops. Dump style 3 is not possible. And so let's change this to dump style 2, and we just read the hexadecimal values. But of course, these are non-readable values. I can't even figure out what this is. Of course, I mean, in human readable form, I can't. So what are our next steps here? For one, if you're on Enterprise Edition, and this is one thing that I strongly recommend that you practice. If you have Enterprise Edition, try doing page level restores, typically known as partial database availability. In this case, I am simply restoring. Imagine this backup file to be 700, 800, or even 1 terabyte size backup. I'm not restoring an entire 1 terabyte backup. I'm only restoring page 297 because that's the only thing that got corrupted. I'm going to restore that, run, and done. Now, the beauty of this is I could query the database. I can query the database. Okay. The database is only offline in that brief period that SQL Server has to kick the users offline and then or kick the users out of the database and then quiesce the database so that I can restore that specific page. So the database is available. And what I can do next is I could take the tail of the log backup, because the goal is, if say this backup was taken last week, I want to bring that page up to today's current state. So I'm going to take the tail of the log backup, and let's restore tail of the log backup. Okay. Whoa, I've got some issues with restoring it. The error message tells me an earlier log backup that includes LSN blah 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 can be restored, which means the tail of the log backup is so recent, which means there are log backups that happen between this and the tail of the log backup, which means I need to find those. So if you have a log backup running on a regular basis, you got to restore all of the log backups. Or if you have a combination of differential with the log, you have to restore the backup that would take the tail of the log backup and get all of the log sequence in a consistent state. So in this case, I'm going to restore the log backup that I took after my full database backup. Done, and now that that works, I can now restore my tail of the log backup. Word of advice: make sure you test your backups. I've had a case in the past where I think that was 4 years ago when one of my customers, they're running on Enterprise Edition, and I've done a lot of page level restores in the past. In fact, I've written an T-SQL script that automates reading the log backups and restoring them in sequence, and then restoring only the page that comes or that was corrupted as part of that. But unfortunately, even though I could do that, the backups contain the corrupted pages. So I don't have any choice. And I can't really do much about that. Keep in mind that your database backups need to be tested on a regular basis. Now, so going back to the demo, now that I've restored a page from my backups, I can validate whether or not my database is in a consistent state. And we could verify that by running the same query that we had earlier, returned all the rows that I have in my query, and no corruption whatsoever. And again, I'm only walking through the process of identifying and dealing with corruption for this particular presentation. So we've dealt with non-clustered index corruption and how to perform page level restore. There are a couple of references that I want you to take a look at. Number one is Paul Randall's blog. And Paul Randall wrote DBCC Check DB. And so he's got the inside information of how it works, what it does, and how you can maximize the usage. I've also included part of the course, your Udemy course. I just forgot what lesson it was, but it's also on YouTube and how under the database recovery techniques. And the last demo of that is doing page level restores, just like what I did in my my last demo. There's a bonus that I want to offer you as part of just attending this webinar. If you visit that site, I'm actually running 2 virtual classes, one of which is a live version of the Udemy SQL Server High Availability and Disaster Recovery course. And I'm including some topics on SQL Server 2014, delayed durability, and some of those. And the other one is Windows Server failover clustering for SQL Server DBAs, because availability groups and failover clustered instances depend so much on Windows Server failover clustering. I find that more and more infrastructures are not properly designed because they don't have an understanding of how Windows Server failover clustering works. So if you head over to the site, use the code when you register, you get a $600 discount as part of doing that. In fact, why don't I do this? Why don't I do 2 things? Number one, let me show another poll. There you go. Are you interested in an in-depth training course on dealing with database corruption? Just start to finish, basic, and intermediate, and advanced topics on database corruption. And again, feel free to ask questions on the chat window, and I'll be more than happy to answer those questions for you. If you're interested, just feel free to answer the poll. And let me also direct you to this offer that I was mentioning for a limited time only. You could register for my virtual class, and again, I'll be running 2 virtual classes. One on the SQL Server High Availability and Disaster Recovery Deep Dive, and the other one is Windows Server Failover Clustering for SQL Server DBAs. Feel free to use the code, all caps, to take advantage of the price offering, and it's only limited for the next 3 days. And of course, maximum number of attendance, either or. If you register, you use that code before I think the 12th of June, you get a discount. And if you're one of the few, I'm only gonna take in few people in the class. I'm going through some of the questions. Okay. Again, thank you so much for attending. I appreciate you taking the time off of your busy day to look into this session. If you are interested in future topics, feel free to send me an email. I'll be more than happy to do them in future webinars like this. And if you could post in the chat window, whether it's questions or comments, what is one key takeaway that you've gotten from this webinar? What is that main topic, main takeaway that you've taken? What is that one thing that you've taken away from this presentation? So I'm looking at some of the comments there. David is a full-time DBA, or a dedicated DBA rather. Tatiana is a DBA database developer. And again, feel free to post your comments on the chat window. What is one thing that you've taken away from this, and how would you use this information to make sure that you proactively identify and deal with database corruption? So feel free to post those questions in the chat window. And if you have any feedback, if you have any comments at all with regards to the topic, again, feel free to post those in the chat window as well. Be more than happy to address those for you. Some of you mentioned that you're interested in an in-depth training course on dealing with SQL Server database corruption. Like I said, there's a couple of things that I've done in the demos that I have not talked about, like how I caused the corruption, in how I've engineered some of those scenarios that I've seen on a regular basis. I can cover that in more depth for possible course on database corruption. All right. And with that, thanks everyone for coming. I really appreciate your time and effort, taking the time off of your busy day to do this. Feel free, again, to send me an email. I'll be more than happy to answer those questions for you. And with that, thanks. Enjoy your day.